Okay, 2.8 number 15 is asking us here just to show that e to the x plus natural log of x equals 0 has a solution. Now you'll notice they kind of took off some of the training wheels that they've given you on some previous problems. They didn't ask you to find where that solution was. They didn't say it had to be in a set interval. They're just asking you to take this equation and show that it has a solution. Okay, well they did us a favor. They've already given us an equation here set equal to 0. So I'm just going to put an f of x in front of that. And now let's go right to our table, guys. X and f of x. And let's see what we got here. We're trying to find where this is equal to 0. So again, I'm looking for a sign change in that f of x column from positive to negative or vice versa. Now, one thing you want to be careful of right here, 0 is not an x value that you can put into this function. Why? It's not in the domain, guys. E to the 0 exists. That's equal to 1, but the natural log of 0 is undefined. So, no help right there. Boy, although now that I think about that, I wonder if that isn't something I'm going to need to consider here in my answer. So I'm going to leave that there. I think I see why. I could be wrong. What happens when we put in a 1? This now becomes an e to the first power, which is just e, and this one I think I can do by hand, plus the natural log of 1 is 0, and we just end up with a y value of e, which is roughly positive 2.718. You know what, I'll go ahead and write that down just in case you guys have forgotten what e is roughly. And I've got a feeling then that when you went to 2, you found something you didn't like. Let me go ahead and put that one in. I think. Let me go ahead and go back to my calculator right here. Okay, and let me redefine this function right here. So I am going to define, here we go, f1 of x, got it, to equal. All right, and let's redefine it for this function right here. So it began as e to the x power, right arrow to get out of there, and then it was, shoot, a minus or a plus, I forgot. E to the x plus natural log of x. Okay, so e to the x, there it is, plus natural log of x. And let's hit enter, and there you go. And just to make sure I'm right so far, okay, let's see what happens when we try to do f1 of 0. This is what I told you guys was going to be undefined. Sure enough, it is. And just to make sure we're on the right track, f1 of 1, that one should have gotten us a value of e. There it is, 2.718. And I think now, when you go to do f1 of 2, this is where I would have expected some of your hearts to break a little bit here, guys. What we would really like to see is a negative value that comes in right here so that we can say, we changed from positive to negative, therefore this equation must have a solution. But I'm pretty sure as I looked at this, guys, or as I thought about it, e to the second power is positive. The natural log of 2, if you guys remember what the graph of the natural log of x looks like, it hits this point right over here, which is 1, 0. So the natural log of 2 is here somewhere. That y value is positive as well. I believe that when we put in a 2, you're going to get a positive plus a positive. We're going to get another positive result here. Let's just see if I'm right about that. I'll go ahead and do approximately equal to. Yeah, that came out to 8.082. That's no help. And I'm pretty sure now you can see the writing on the wall here if you think about it, guys. If I do f1 of 3, I think this is going to be another positive plus positive. Shoot, that one's positive as well. And I'm pretty sure if I kept doing this for any integer moving forward, I don't know, f1 of 11, just for example, that's going to get you, oh man, an even bigger positive number. So it really seems right now that if we keep doing this here and here and here, we just keep getting positive after positive after positive, and that doesn't help us find a solution. So where are we supposed to look? I think the key here, guys, is the fact, and I alluded to this a second ago, that this function is undefined right here at 0. But that doesn't mean that it's undefined somewhere in between 0 and 1. So let's just try real quick, guys. I'm going to switch colors on you here. What if I put in a number between 0 and 1, like, I don't know, 0.5? Now, when I take e to the 0.5 power, now remember e to the x, everybody, looks like this. E to the 0.5 power is going to be a positive number right here. But the natural log of 0.5 is actually down here somewhere, you guys. That's actually a negative value. So it's possible that when I add this positive number plus this negative number, I might end up with a negative y value overall for the function. So let's try to evaluate this function again. So that will be f1. And let's try to evaluate this at 0.5. Ooh, that one still ended up positive, but it did get a little bit lower. But I bet if I keep hunting right here, guys, I bet if I did f1 of how about 0.1, there it is. There's the negative value, not the only one, but there's a negative value that I was looking for, negative 1.197. So I better write that down. Maybe I'm going to change my table here just a little bit. Ooh, what have I done? Oh, Mr. Fontana, that's not good. Okay, give me a second here. Can I get back to this? Sorry, guys, this document has like a million pages in it. All right, so where were we right here? Let me get rid of that 0.5 and make it a 0.1, and that was a negative. Now I forgot what it was. At 0.1, we got a negative 1.197. Okay, negative 1.197, and right here, everybody, that is what we were looking for right here. We went from a negative y value at 0.1 to a positive y value at 1. So somewhere in between 0.1 and 1, there's got to be a spot here where our y value is equal to 0. Now, reading my directions, the problem did not say narrow that down. It didn't say use the bisection method. It just says prove that it has a solution. So the fact that I've shown that this function can be negative and then it can be positive tells us there's got to be a solution somewhere there where the value of that function is 0.